Today we're going to talk about direct variation, which is also called graphing a proportional relationship. Let's see if we can determine the two quantities in a graph are proportional by graphing. You can tell if they're proportional if the graph makes a straight line, that's the first thing, and if the line goes through the origin 0, 0, that's the final decision maker, then it is definitely a proportional relationship. Let's look at this sample problem here. Reading the story, the black mamba is the fastest snake in the world. The table shows the distance that the snake travels over different times. Is the distance proportional to the time? The first thing to check is, does the graph go through 0, 0? And yes, it does. And next, check to see that it is a straight line. And it is a straight line, so the answer is yes, this is a proportional relationship. You can check your answer by finding the unit rate of the two quantities involved, which is time in seconds and distance in meters. So we always report this y over x. We see that this is going to be a 5 over 1. This is also 5 over 1. This is also 5 over 1. And the last one's 5 over 1. So they are all equal. This means there's a proportional relationship between distance and time. We did not include the 0, 0 time and distance because you can't divide by 0, so this fraction can't be made for us. If the unit rates are all the same, then we can say there is a constant of proportionality, which is 5 to 1. And this ensures that, yes, there is a proportional relationship between distance and time here. Okay, it's your turn. Try this. And this story reads, a candle is 20 centimeters tall, burning at 2 centimeters per hour. And the question, is the height of the candle proportion to the number of hours burned? The first thing we look for is the line straight, and it is a straight line. The next thing we look for, does it go through 0, 0? And the answer is no, it does not. So we can say that no, this is not a proportional relationship, but we can check it with the unit rates. The first one is 18 to 1. The next one is 8 to 1. The next is 14 to 3. I can't simplify it more than that. The next one is 3 to 1. None of these are equal to each other, so this checks the fact that this is not a proportional relationship because it does not have a constant of proportionality, or they don't all have the same unit rates. And note that we did not use this, which would be 20 divided by 0, because you can't divide by 20. You can't divide by 0. Next, let's try to explain some of these proportional relationships a little better. In this example, one quantity is the stretch of a spring. We're asking, is it proportional to the weight that you put on the spring? First of all, we can see that it is a proportion because it passes through 0 and the line is straight. And then we look at the unit rate, which is y over x. This is y, and this is x. And both of our comparisons of y to x are 5 to 1. So this unit rate describes that there are 5 millimeters of stretch for every gram of weight that you put on the spring. Again, we don't use this because we can't divide by 0. Now let's explain the points that are present on the graph. First, the point 0, 0. This represents the length of stretch of the spring, which is 0 millimeters, when there is no weight at all attached. That makes sense. The point 1, 5 says that for every 1 gram of weight, the spring will stretch 5 millimeters. And the point 5, 25 says that for every 5 grams of weight placed on the spring, it will stretch 25 millimeters. I would like you to explain this one to me. In this problem, Keith is planting a seed, and every 3 days, he watches the seed sprout, and he measures the height, and he graphs the results. So he has two quantities, height on the y-axis and day on the x-axis. First, we see that it is a proportional relationship because it goes through 0, 0, and it's a straight line. And when we look at the unit rate, which is y over x, also known as the constant of proportionality, they are all equal at 2 millimeters of height for 1 day, and we don't use the 0, 0 because we can't divide by 0. And if we explain what these points mean, the 0, 0 means that we planted it on day 0 and there was 0 growth at that point. On the third day, it had grown to a height of 6. So the 3 is the day and the 6 is how high it grew. On the 6th day, it had grown to a height of 12 millimeters, so 6x, 12y. On the 9th day, it had grown to 18 millimeters, so that gives us 9, 18. And now you know how to grow and measure seeds.